Okay, what we're looking at today is postulates and theorems. And the worksheet looks like this. What we're going to do first is fold it over here to the dotted lines, and we're going to go over these postulates. What postulates mean are just rules, and then axioms are the result of those rules. So let's take a look. Through any 2 points. So what you need to know is that they're going to talk about 2 points first. When you have 2 points, there's exactly one line. So when you have any 2 points, A and B, you can draw one line through them. It might look the same at the end, but what you start with is what's important. Through any non-collinear points, there exists one plane. So what you start with is 3 points that are not linear. That means they're not on the same line. Then that is enough to make the plane. Number 3, a line contains at least 2 points. So what they want is a line first. When we have a line, that means that there's at least 2 of them. Well, there's a lot of them. We just need to know 2. Number 4, a plane contains at least 3 non-collinear points. So we have a plane first. So I want you to notice number 1 and number 3 end up looking the same, and so will 3 and 4. So what you start off with is what matters most. That's a plane that we have first. Because we have a plane, we know we will have 3 points that are not collinear. Number 5, if 2 points lie on a plane, then the entire line containing those 2 points lies in that plane. So what does it mean? You have 2 points, A, B. If they're in the same plane, then the line that is formed with them is also on that plane. Number 6, if 2 lines intersect, then their intersection is exactly 1 point. Well, we know this from algebra, that we have 2 lines like this. The point of intersection is that one right there. Let's review just a little bit. How about lines like this? If they don't touch, they don't intersect, then there's no solution, no intersection. How about if the line is on top of another line? How many solutions or intersections are there? Infinitely many. It's just kind of something that we need to review, so that's why I brought it up. But this is what the theorem is talking about. Number 7, if 2 planes intersect, then their intersection is a line. So what is it talking about? And this is demonstrated easier with actual planes. I'm going to take this plane right here, and I'm going to intersect it with this one right here. So where does it touch? All throughout this line. So 2 planes that intersect at a line. The theorems. What a theorem is something that needs to be proven. Somebody has already proven these things, these conclusions, to be able to call them theorems. Properties are just algebraic rules that we have had for a long time now. So let's take a look at midpoint. Midpoint has a definition like this. If M, the point M, is the midpoint of AB, Don't forget we have to call it segment AB. Then AM, and we don't have to put the line for segment because we're going to say is equal to MB. What does that mean? That means that if I had this segment right here, AB, and I purposely put a point M in the middle, then this length is equal to this length. And we denote it like this, so we can tell that they're the same. Congruence theorem. What congruence theorem tells us when we're talking about segments is that if we have AB, the segment AB is congruent to the segment CD, so don't forget the notation at the top, then AB is equal to CD. So what's the difference? This congruency symbol is used when we're talking about the picture. So for example, AB, CD. We don't know how long they are, but they're telling us that these pictures are the same. When we use the equal sign is when they're telling us that the measurement is the same. So now they're telling us that if these two pictures are the same, then their measurements must be the same. Angles. How we make the notation for angles is this way, like a less than symbol. And this is congruency theorem. So this angle, we're going to be talking about it in terms of congruent. I'm going to call it angle 1. Is congruent to angle 2. Then, that means that the measurement of that angle 1 is equal to the measurement of that angle 2. So similarly, they're talking about the picture of the two angles is the same. That means that their measurement has to be the same. The transitive property. The transitive property looks like this. If x is equal to y and y is equal to z, then x is equal to z. I want you to notice this right here. It looks similar every single time we see the transitive property, so that's what you're looking for. The reflexive property is like a reflection. So this one looks like 4 is equal to 4. It's the same on both sides of the equation. The symmetric property looks like y is equal to x is equal to y and y is equal to x. So they switch the order, but they mean the exact same thing. Now if we open it up, this would be the application of those things that we just saw. On the first thing, it says name the postulate that shows each statement is true. So it says line E. See how this is a cursive letter that's off to the side? That's talking about this line right here. So they want to talk about first a line is in the plane M. This one, it says through 2 points, through any 3 collinear, a line. There we go. A line contains at least 2 points. Well, it didn't talk about points, so it wouldn't be that one. A plane? No. If 2 points lie on a plane, then the entire line containing those 2 points lie on that plane. Let's see if that one works. The line in that plane. Well, does it have 2 points on the plane? Yes. And that's the one we're looking for, so we're going to write down postulate number 5. the next one. It starts with points A, B, C. That means we're starting with 3 points. Through any 3 points. Very good. Non-collinear. I think those were. Let's check. Non-collinear means that they were not on the same line. A, B, C. They were not on the same line. There is exactly one plane. There is one plane. It's coplanar. They're in one plane, same plane. And then that's exactly the one we wanted. Postulate number 2. Next, determine whether the statement is true sometimes, always, sometimes, or never. So the first one, 2 points determine a plane. 2 points determine a plane. Oh, sorry, 3 points. 3 points determine a plane. That is sometimes true. Why? Because they can't be collinear. So if you gave me 3 points that were on the same line, then that's not enough to define a plane. So take a look at this one. 2 planes intersect at a point. 2 planes. So that was the illustration that I gave you this way. 2 points intersect at a line, not a point. It has a whole bunch of points, but where the intersection is a line. So this is never true. Because they intersect at a line, not a point. Let's take a look at this one over here. A plane contains at least 3 points. Well, let's draw a plane. Does it have 3? Yeah. Could it have more? Absolutely. But since it's defined by 3, it will have at least 3. All the time? Always. A line and a plane intersect at a point. So this is easier to demonstrate with this. I'll put this down. And then let's pretend that this is the plane. Then this is the line. It intersects at a point. At one point. No matter how we tilt it, it's always going to touch the plane at just one point. So a line and a plane intersect at a point? Yes, but how about if the line is laying down on the plane? That's a whole bunch of points that it will intersect at. That means a whole bunch, making our answer sometimes. Why? Because the line can be on the plane. So this is one way that during a test or homework assignments, we would be asking you to use the rules that you know. The other way is by a proof. You're given the reason for a statement that is given. So, for example, this says that the segment AB is congruent to the segment CD. Then the measurement of AB is equal to the measurement of CD. The reason that we can say that is from the congruency theorem. Next, I want you to recognize this right here. Just from this box that I'm making, you should know the property, but let's go ahead and read it correctly. If the measurement of JK equals the measurement of KL and the measurement of KL is equal to the measurement of LM, then JK is equal to LM. And that's the transitive property. Okay, next. Since point D is the midpoint, so they're kind of telling us which rule that we need to use. And if you don't remember, that's what the notes are for. And please take a look at them and try to remember which one it is that we were talking about. So we should know the answer just by that word, but let's read it. Since D is the midpoint of the segment CE, then the segment CD is equal to the segment DE. That's by the midpoint theorem. Next, it says if MN is equal to PQ, then PQ is equal to MN. So what they did was change the order. They just changed the order. That would be the symmetric property. Again, if you did not know that that's the property, what you would do is just look back over here and see which one best fits. This one says, if angle ABC is congruent to angle DEF, then the measurement of the angle ABC is equal to the measurement of the angle DEF. So the only difference was the symbol, making it the congruency theorem. Congruence theorem. ST is equal to XT, ST. It's just like a mirror, making it the reflexive property, like reflection. All right, make sure you staple this on your notes so you'll be able to use it on your test.